Okay, ji, Bismillahirrahmanirrahim. Today we will discuss about chi-square test. It is most widely used in any discipline, specifically in healthcare. Why we use chi-square test? When we need to see association between categorical variables. Whenever we talk about categorical variables, there are nominal and ordinal. If you remember, we have already done few sessions on type of data, nominal, ordinal, interval, and ratio. You need to revise if you didn't remember. If we have nominal versus nominal data, then we will apply chi-square test. But the issue is chi-square test has certain limitations or certain checklists, certain requirements. When those requirements are fulfilled, then we will apply chi-square test. Otherwise, there are more tests available. We will see, and we will see the conditions as well, and we will apply the relevant statistical tests. If you know to see the association between, for example, smoking versus gender, for example, low birth weight, the status is yes, no, and maternal anemia, the status is yes, no. Low birth weight is also nominal. Maternal anemia, yes and no, is also nominal. So whenever there is condition, there are two variables and both are nominal, both are categorical, we apply chi-square test. For example, I have added two example here. We can see more example by looking at, for example, obesity, yes or no, versus cardiovascular diseases, yes or no, or obesity versus risk of knee osteoarthritis, infection versus type of antibiotic given. If there are more than two categories or only two categories, it doesn't matter for chi-square. There may be two categories, there may be three categories, there may be four categories. A chi-square test can be applied on any number of categories for categorical variables. Why we use? When we need to see the association, but no correlation. Usually our students, and we make the mistake that our objective is to see the correlation and we apply the chi-square test. Correlation is used for quantitative data, but if your variables are categorical, we will apply chi-square test. When there is association, when we can claim then that there is association, we can claim that there is association if p-value is significant. What it is meant by p-value is significant, as we use SPSS, and if p-value is less than 0.05 or p-value is less than our selected alpha, we say there is association. So, for example, if I say I want to see body mass index versus body mass index of mother versus birth weight. Look, body mass index of mother is also quantitative. Birth weight of baby is also quantitative. Can we apply chi-square test? You can write in chat box. Can we apply chi-square test? Both are given in numerical. Please quickly type yes or no. No, no, no. Very good. Because both are quantitative. If both are quantitative, then we will apply correlation test. When it is significant, it's significant when p-value is less than 0.05. So there are certain examples that we, if you people now think that I have objective of correlation, but I applied association, or my variables were categorical, but I wrote correlation, it was not appropriate. I don't say it is wrong. It was not an appropriate term. Correlation is not appropriate term that is being used for the purpose of seeing association or for the purpose of analyzing categorical data. So when we apply category chi-square test, if there are certain assumptions that I told you that I will show you at the output sheet of SPSS, then we will learn when chi-square may be applied or when Fisher exact test may be applied. There is another concept of odds ratio. I had already shared a recorded lecture with you people about odds ratio, but I felt that it should be revised because we are doing we are doing for categorical data. I will take question answer session after the lecture. You can keep your questions written somewhere, then you can ask, please. Odds ratio is basically what is the relationship between chi-square test and odds ratio. Chi-square test sees association, while odds ratio tells us the risk of disease, for example. We are working on some disease based on some risk factors. If I say that is there any risk of disease in the presence of smoking, we will say we will apply odds ratio. If we want to check the risk of disease in the presence of some risk factor, we will apply odds ratio. So odds ratio and chi-square test are basically used for categorical data when we have two cross two table. Odds ratio can be calculated for other type of variable, but I am talking about two cross two table right now. When we want to see the association, we will apply chi-square. When we want to see the risk of disease in the presence of only one risk factor, we will apply odds ratio using 2 cross 2 table. If there are more than one risk factor, then we will learn sometime how to calculate odds ratio and which techniques are required. The odds ratio is basically lies between between you can say 0 and infinity. It can never be negative. Odds ratio can never be negative. If it is less than 1, that risk factor is protective. If odds ratio is 1, no relationship or no risk. No risk is calculated, or there is no risk of the disease in the presence of that particular risk factor. If odds ratio is greater than 1, there is risk of the disease in the presence of that variable. Now, for example, if odds ratio is 1, there is risk. But along with all these things, we need to see the p-value as well. If p-value is significant, this odds ratio will be significantly contributor, and that p-value will be from chi-square test. Remember, odds ratio, the p-value for odds ratio is never calculated. There are certain errors that we make, and whenever we review any article or whenever we review any student, we say that calculate p-value based on odds ratio. It is not. It is never be calculated for odds ratio. For odds ratio, we calculate 95% confidence interval. This 95% confidence interval, and we say it is significant. It's significant. What's significant? Odds ratio is significant if it does not contain 1. Here is some technical aspects of understanding odds ratio. Like I told you, we say that it is significant if it does not contain 1. For example, the odds ratio is less than 1, let's say 0.5, and the 95% confidence interval comes like this, 0.2 to 1.5. Look, this interval contains 1. I mean 0.2, 0.3, 0.4, 1, 1.1, 1.2, then 1.5. If there is 1 in the interval, this odds ratio is not significant. Although it may be contributor, but this contributor is not significant. Suppose there is another odds ratio for the risk proven, and the odds ratio is like 1.5. We will say that there are 1.5 times higher chances for disease in the presence of this risk factor. But is it significant? We need to see its confidence interval. If, for example, if its confidence interval is 1.1 to 4.3, look, it is beyond 1. It is above 1, 1.1. So 1 is not containing in this 95% confidence interval. We will say this is significant risk factor. If my odds ratio is suppose 1.7 and confidence interval is 0.922, suppose 0.9, then 1, then 1.5, then 2. It contains it contains 1. It means this 1.7, the odds ratio 1.7 is not significant contributor. It may be by chance. So for chi-square test, you only need to see the p-value. And I'll tell you when to apply a Fisher exact test while practicing. For odds ratio, you need to calculate odds ratio. And if it is less than 1, it is protective. If it is greater than 1, it is risk factor. But whether it is significant or not, you need to see if it is significant, it should not contain 1 in 95% confidence interval. So let's go to our SPSS file. For our SPSS file, I am using the same file we have already been used for various practices. Suppose there is a study group preterm and full-term birth. There is demographic variables. There is another demographic, anthropometric variable. Its profession of mothers, its neonatal gender, its neonatal weight. It may be less than 5 or more than 5. If it is less than 5, it is low birth weight. If it is more than 5, it is normal birth weight. It is city, and the other variables are also taken. So if you want to apply chi-square test to see the association, there are certain chi-square tests like there are other chi-square. The purpose of chi-square test may be different than association, but right now we are talking about to see or to check the association between two categorical data. If you go to analyze descriptive statistics, here is crosstab. Usually people are trapped not to find the crosstabs or chi-square test because it is given in descriptive test. Although it is type of inferential test, but it is given in crosstab, in descriptive under crosstab, because crosstab is simple crosstab is descriptive, and in its option, when we will apply some test, it will become inferential statistical test. Suppose, look, what is dependent? Always remember, the dependent variable is taken in column. My study group like preterm birth and full-term birth is my dependent variable. I will take it in columns. And suppose I want to take age of mother as independent risk factor. If the mother's age is greater than 35, it's proven that studies prove that there are higher chances of pregnancy complications or maternal outcome. If I again apply profession status of the mothers for working women, there may be higher risk of like preterm birth. But let's analyze only one variable. On your right hand side, you can see that there is statistics, there is exact, there is cell, there is format, there is style, and other things are given. Even you can click display cluster bar. It will make the bar of the variables. I'm not clicking any test. Let's see what will happen. Did you see the output sheet? There are 100% valid. There is no missing data. And here is 2x2 table is made. For output sheet is not visible. Can't you see 2x2 table, please? Okay. Can you see now? 2x2 table is given. Can you see now, please? Okay, thank you. 2x2 table is given. Here is full term, preterm, less than 35, greater than 35. Here is the bar chart. It's fine. Okay. Now let's apply chi-square test on this table. Okay. Again, go to analyze, descriptive statistics, crosstab, statistics. You can apply chi-square here. You can see there are various tests available, like you can apply correlation, but this correlation is not Pearson correlation, like quantitative versus quantitative. This is not that correlation. Contingency coefficient. There are certain tests available. I do not want to dive into these tests. Let's learn about chi-square test first. Press continue. You just press on cells, press on columns, continue. Okay. So if you see, again, such summary is being generated. Mother's age less than 35. This is greater than 35. Full term and preterm. Here is the chi-square test that is applied. The value of chi-square test is 3.007. Degree of freedom is 1. 0.083 is the p-value. If you see, this is p-value. But before reporting this p-value, you need to read the footnote of this table. It is saying that 0 cell have expected count less than 5. If it is a 0 cell have expected count less than 5, you will see the value of chi-square. If it is 50% or more, because there are only 4 cells, if it is not 0, you will see the value of Fisher exact test. Chi-square is wise enough, SPSS is wise enough. It will give you the output of chi-square test, and under chi-square test, it is giving you the test of Fisher exact test. There are other tests too, but we will not again discuss those tests. We will have other session about linear bilinear association, continuity correction, likelihood ratio. We can see later, but you can see if this is not 0, if there are 25%, if there are 50%, if there are 75%, or if there are 100%, because there are 4 cells. If one cell has less than 5, it will be 25%. If 2 cells have less than 5, it is more than 50%. If 3, 75%. If 4, it is 100. You just need to read this line. If it is 0, you will apply chi-square test. If it is not 0, you will apply Fisher exact test. Now, you just need to see what is this two-sided and one-sided tests. These two-sided, because I have already generated my hypothesis that there is no association, there is association. And when I say that there is no association, it means it is two-sided. And usually for chi-square test, for association test, we usually claim that there is no association and there is association. We may add that there is positive association, or there is one-sided association, there is negative association, but usually we make two-sided. So always see this p-value for chi-square test and this p-value for Fisher exact test. So let's see if it is significant or not. This is not significant because our p-value is 0.83. This 0.83 is greater than 0.05. If this is greater than 0.05, it is not significant. When it is significant, if it is less than 0.05. If you see the notes I have shared with you, it was already written there. It was already written there. If p-value is less than 0.05, then it will be significant. So it is not less than 0.05. So we will claim, or we will say that our association between study groups or preterm is not associated with age groups. Let's analyze more. You can press this recall box and go to crosstab. Other than this age of mothers, let's see BMI, profession, neonatal gender, neonatal weight, and the city as well, because it is also nominal. I have simultaneously put all the variables in my rows, and I will see the SPSS will generate all the table with each and every individual variable. See, is the p-value is significant or not? It is between study groups and the body mass index of the mothers. It is underweight, normal weight, overweight, obese, and we can see that if it is significant or not. This 0.025 is basically 0.025 is significant, and Fisher exact test is not calculated here. There are multiple theories available. One theory is if the cell is more than 50% cell have less than 5 expected count, then we apply Fisher exact test. For example, you need to apply Fisher exact test here. I'll tell you in next command. But in while looking at Pearson chi-square test, it is significant. You can claim that there is association between preterm birth and body mass index of the mother. Now you will see at the percentages. Look, this is 4.1%, 32.7, 22.7, and 40. For preterm birth, obese, overweight, and obese are making the higher ratio. If they are making the higher ratios, almost about 63%, there were 63% of female who delivered preterm birth and they were overweight or obese. So preterm birth was associated with overweight and obese. This is the right way to interpret your table. You need to see on the percentages. How I calculated percentages, while shifting the variable there, I pressed the cells, and after pressing the cells, I pressed columns. And after pressing column, it is calculated, percentages are calculated on the basis of these columns. Because I have already checked to generate the bar graph, so it is made by default. Is there any association between working status of mother and preterm birth? No, there is no. Look, if it is 2x2 table, Fisher exact test is by default calculated. If it is not 2x2 table, it is not calculated. In this case, if you apply Fisher exact test, look at the p-value 0.171. 0.171 is greater than 0.05. So there is no association between preterm birth and profession of the mothers. Here is neonatal gender. Usually it is said that preterm birth is associated with gender. If baby is male, there may be higher chances of preterm birth, but our data suggests that there is no. Zero cell count mean, we will see p-value of chi-square test. It is 0.5, 0.55. It is greater than 0.05, so we will not apply chi-square test. Again, bar chart is made there. Is there any association between neonatal weight and preterm birth? Look at the p-value. As zero cell have expected count less than 5, we will see the p-value of chi-square. Yes, it is highly significant. The association is significant between preterm birth and neonatal weight. We can say that there were in preterm birth more than 25 kg neonates had weight more than 25, and here look at this is 7.9, this is 44.9. So you can say that in preterm birth the ratio of less than 25 or low birth weight is higher. So neonatal weight or low birth weight is associated with preterm birth. Then we can see this association between city. So this was data of Punjab. No 2x2 table is generated here. No chi-square test is generated here. And by default, this graph was made. So it was all about chi-square test and Fisher exact test. Now we will move for suppose for odds ratio. But for odds ratio, you need to manage your data. You need to manage your data like your variable of your interest should come first. Here, preterm birth was at the end, but for odds ratio, you see this preterm birth should be here, and this greater than 35 should be here, because as per the formula of odds ratio, it is AD over BC. What is A? A is suppose true positive and D is false positive. We usually make the mistake that we do not consider the coding scheme while analyzing odds ratio. So we need to consider the coding scheme while analyzing the odds ratio, while calculating the odds ratio. So if I make 2x2 table here to make you people understand, because this is very much important and crucial to generate odds ratio from 2x2 table. Suppose here I insert my 2x2 table. Suppose this is my disease, any disease. It should be yes and no. If there are my risk factors, it should be yes, then no. Here is A, here is B, here is C, here is D. So the formula for odds ratio is always AD over BC. AD over BC. But in my current scheme of SPSS, this was basically disease, and this was the risk factor. Greater than 35 was the risk factor. They were not on the right place. So to make them on the right place, I need to recode my data. It's another debate how to recode my data. But for quickly, let me do something so that I can convert it into what I will do. For example, low birth weight, I will make this as 2. I have changed the code, and for preterm birth, I will also make it full term as 2. Okay. Here what I will do, I will just replace all the zeros with 2. I have just recoded my data in order to calculate odds ratio. If you are working on single sheet, you have to make other variables, or you can generate another sheet to calculate odds ratio in this case. I will do the same with study groups. I will sort ascending. I will do sort ascending. I will press 2. I will copy. There are other shortcut ways, but I just wanted to let you people know how to do it manually. Okay. Now again, go to cross tab. I will just select neonatal weight. On your statistics again, press risk. This risk will give me odds ratio. Continue. Okay. Output file is again there. Here is the 2x2 table. Look, preterm birth is coming on first place and less than 25 because it was also the complication or the risk factor, whatever you say. Basically, the purpose is to take less than 25 low birth weight at first place. So here we have already seen that it was significantly associated. And if you see the odds ratio 9.43, it means for preterm birth, there are 9.438 times higher chances of low birth weight. Listen the interpretation again. For preterm birth babies, there are 9.438 times higher chances of low birth weight. And if you see, it is the 95 95% confidence interval. You just see it's starting from 4 and ending at 21. Does it contain 1? No, because 1 is before 4 and it's starting from 4. 4 to 21. There is no 1 in this interval, so our odds ratio is significant, is meaningful, is valuable. We should consider the risk of low birth weight for the preterm babies. So it was all about chi-square test, Fisher-Exact test, and odds ratio. If you just see what we did, we just managed our 2x2 tables while calculating odds ratio. Rest, there was no technicalities. Okay. Now, if there is any question you may ask. Okay. The hand is raised from Amber Nawaz. Yes, you can ask, please. There is no voice from Amber. Amber, you can ask, please.
अस्सलाम वालेकुम सर।
वालेकुम सलाम।
सर ये मैंने कहीं पढ़ा था कि जब एंट्रीज जो हैं इन किसी भी सेल में लेस देन 5 या मिनिमम 5 हो तो फिर हम जो है वो काई स्क्वायर
It's wrong. It's wrong. These limitations are only for expected count, not for entries.
Okay.
It's a general concept that I have also had the query from a professor. He was saying because this cell has 2, we will not apply chi-square. Actually, cell doesn't matter. Expected count matters. Do you know how to calculate expected count?
No, sir.
Okay, let me tell you how to calculate expected count. It's basically mathematical steps, but our SPSS can calculate expected count as well. If I go to cross tab again, cells, from where I calculated my percentages, here is observed and expected. If I pressed expected, just continue, just okay. Look, this cell has count was 22, but expected count was 8.3. It was 27, but it was 40.7. It was 12, but it is 25.7. It was 139, but it was 125. So this expected count should not be less than 5. This expected count should not be less than 5. Yes, Shaza Shahid.
If it is less than 5, then sir,
then we will apply Fisher-Exact test.
All right. Thank you, sir.
Welcome.
Assalamu alaikum, sir.
Walaikum salam.
Sir, my question is about this expected count. What is the difference between observed and expected count?
Observed is what you... Yes, please.
जी, और सेकंड ये कि सर जैसे हमारा कॉन्फिडेंस इंटरवल 4 से 21 की रेंज में है, which is quite broad, तो इससे कोई फर्क नहीं पड़ता कि broad भी है तो हम रिपोर्ट कर दें, but it's significant.
Yes, it should be reported. It should be reported. Why it is broad? Because you see the frequency for preterm birth and full-term birth, there is huge variation. Look at the percentages.
Okay.
Look at the percentages, 44 versus 7.9. 55 versus 92.1. You should report there is no issue. And your first question was about?
Observed and expected.
Yes, observed, expected. Observed is what we are collecting the data. Expected is if we do it again, what will happen? What is the expected count for the next time? So if it is less than 5, we will apply Fisher-Exact test. Okay, it is basically expected, not observed. You just see what you observed and what was expected. What is observed?
और सर इससे कोई फर्क नहीं पड़ता कि जैसे अब यहाँ पे भी हम देख रहे हैं कि एक ग्रुप जो है जैसे फुल टर्म 7.9% है और प्री टर्म 4% है, फॉर एग्जाम्पल जैसे हम क्रॉस सेक्शनल स्टडी करते हैं तो उसके अंदर हम नेचुरल ग्रुप्स बना लेते हैं कि इतने मेल थे और इतने फीमेल थे.
Yes, it's
अब मेल,
look, it's defined group because it is defining the low birth weight.
जी
There should be logical consideration while making the groups, and this is a it is logical to make the low birth weight and normal birth weight. We shouldn't make a group from our sides. We should not think ourselves what group should be there. Group should be made on the basis of evidences.
सर वो तो ठीक हो गया कि जैसे एक हमारे पास कट ऑफ है कि 2.5 केजी से नीचे हम लो बर्थ वेट लेते हैं.
Yes.
ठीक है सर, वो तो है हमारे पास एक रेफरेंस वेट है. लेकिन मैं आपसे ये पूछ रही हूँ कि जब हम क्रॉस सेक्शनल स्टडी करते हैं और उसके अंदर हम ग्रुप्स में डेटा कलेक्ट नहीं करते,
Yes.
लेकिन बाद में हम ग्रुप्स बना लेते हैं और काई स्क्वायर लगा लेते हैं,
Yes,
तो
yes,
वो तो
it's
ग्रुप
logical.
हमारे पास बाद में आया, तो सर
Yes.
उसमें फिर एक ग्रुप में नंबर 10 लो पार्टिसिपेंट्स 10 बन जाते हैं. फॉर एग्जांपल मेल टू फीमेल हमने बना लिया, तो मेल जैसे 10 हो गए तो फीमेल 100 हो गई, तो
Yes.
सर ये ठीक होता है?
Yes, it's okay. It's collected
इट्स
data.
ओके.
Yes, it's okay. It's based on collected data.
ओके
No
फाइन,
problem at all.
ठीक है,
No problem at all.
ऑलराइट,
Okay,
ठीक.
okay.
थैंक यू सर.
Thank you. Any question, please?
अस्सलाम वालेकुम सर.
Walaikum salam.
सर टी टेस्ट के बारे में अभी कुछ आइडिया होगा कि अभी मतलब इन तीनों टेस्ट के बाद?
Okay, just to compare mean. Inshallah, our next session will be on t-test and analysis of variance. And
Okay.
you don't need to do long wait, inshallah. It will come soon.
Okay, thank you so much, sir.
Thank you. Any question, please?
Assalamu alaikum, sir.
Walaikum salam.
Sir, while doing odd ratio, we recode the data.
Sorry,
But when
while?
we calculate we recode the data.
Okay.
Means we put the pre-term first and full term later. Sir,
Yes.
while on this data, can we calculate the chi-square
Yes,
test?
we can calculate. There is no condition for chi-square.
Sir,
Whenever you need to apply odds ratio, you just consider the coding of odds ratio. No issue for chi-square. It come earlier or later. No problem.
Okay, sir. And sir, the second question is while doing the publication in X category journal, they said that calculate the effect size. Sir, whether in chi-square test we calculate the effect size or not?
I think we should talk later because
Yes, sir.
we will come beyond the chi-square test. Yes, you can.
Sure, sir.
Yes, you can calculate effect size for certain statistical test. I can reply you in person, no problem. Okay, you just
Okay, sir.
send me
Thank you,
the
sir.
query on WhatsApp.
Okay, sir. Thank you, sir.
Thank you. So, is there any question? Okay, let me see the chat box. I think there are.
सर मैंने क्वेश्चन पूछना था.
Yes, yes.
सर कोरिलेशन जो है उस वो एक तो रिलेशनशिप देता है और दूसरा डायरेक्शन देता है.
Yes.
और जो रिग्रेशन होता है वो प्रेडिक्ट भी करता है.
Yes.
तो जब हम एनालिसिस करते हैं तो कैसे डिसाइड करेंगे कि हमने आइदर एक करना है या दोनों अप्लाई
Based
करने
on
हैं?
your objective. What's your objective? आपका स्टडी का ऑब्जेक्टिव क्या था? टू फाइंड द प्रेडिक्टर्स और टू फाइंड द रिलेशनशिप. अगर आपने प्रेडिक्टर्स मालूम करने हैं तो डेफिनेटली यू विल गो टू रिग्रेशन. अगर आपने प्रेडिक्टर्स फाइंड नहीं करने, आपने अगर सिर्फ रिलेशनशिप देखना है तो कोरिलेशन. ठीक है. प्लीज अभी आप लोग जाइएगा मत, लीव मत करें. देयर आर सम टिप्स जो कि मैंने अभी आपको कुछ बतानी है. जी.
सर क्लासिकल सेंस में प्रेडिक्टर कहते किसको है?
प्रिडिक्टर आपके डिपेंडेंट वेरिएबल को जो प्रिडिक्ट करे. कार्डियोवैस्कुलर डिजीजेस को क्या चीज प्रिडिक्ट करेगी? स्मोकिंग. कार्डियोवैस्कुलर डिजीजेस को क्या चीज प्रिडिक्ट करेगी? ओबेसिटी, लाइफस्टाइल. ये हमारी
ठीक.
थ्योरी है. क्या
जी.
प्रैक्टिकली भी ये चीजें प्रिडिक्ट करेंगी? ठीक है, ये एक थ्योरी है ना, तो इसको एविडेंस
जी.
बेस्ड भी तो होना चाहिए. क्या हमारी
बिल्कुल.
एविडेंस एनफ है कि कार्डियोवैस्कुलर डिजीजेस को लाइफस्टाइल, सेडेंटरी लाइफस्टाइल, ईटिंग हैबिट्स, बॉडी मास इंडेक्स, क्या ये प्रिडिक्ट करेगी? हमें देखना चाहिए और उसके लिए फिर हम
सर
रिग्रेशन लगा देते हैं.
ठीक है. ठीक. थैंक यू सर.
Okay, Faiza Gazanfar, inshallah, for sample size estimation, we have plan but that will be extended program for sample size estimation and for certification in SPSS and biostatistics. I have already disclosed in our previous AI workshop. That was an excellent experience we have done with Alhamdulillah 38 participants for AI, role of AI in research. That went very well, and there is another growing demand. Maybe next week we will repeat a role of AI in research writing again, and we will soon announce certificates in biostatistics, certificates in data analysis, SPSS, and this sample size as well. Thank you very much, Saira Bano, Faiza, Shafkat, Khanzada sir. Thank you.
सर मुझे एक सवाल पूछना था
जी
ये chi-square टेस्ट में जब हम करते हैं there's for instance if this is for gender or ethnicity there is significant difference based on chi-square test.
Okay.
So how can you find that which groups are significantly different?
Yes, I just explained from the table. Look at the percentages. Which percentage is which cell contains more percentage? That is basically associated.
Okay. Mm-hmm. Okay, I'll look into my data and see again.
Yes,
Thank you.
You just see the percentage.
Okay.
And one thing more, the thing I told you about codes of odds ratio, it's mostly written wrong in articles. And there is no consideration, just odds ratio is calculated and we interpret and we appreciate. You just see whether this odds ratio is calculated rightly, because when cells will interchange, odd ratio will be wrong. So there is a tip: whenever you read the article, whenever you evaluate the article, just see the 2x2 table and what come in first cell on either side on rows and columns. Okay. And just see if it is disease and risk factor, then odds ratio is okay. Otherwise it's wrong. Thank you very much, Waqas Lateef Saab. What to do about missing data? You have to enter rightly. If there are missing data, you can analyze missing data, replace missing data. But if there is huge percentage is missing, then discard and take another data. Okay, thank you very much. If there is no question, then I will wind it up. And it's requested from all of you to open your cameras for take a group photo. Let me stop share. If there is no question, thank you very much for all those. Dr. Sara, inshallah, we will extend. I will share the recording. Can you open your, please, cameras to take the group photo? I'm going to take, please. Hold your. Please allow कर दें. Have you allowed? Naveed Iqbal sir, you are enjoying?
Yes, sir.
Okay, let's do it again, please. Okay, thank you very much. If you have any query, you can inbox me or you can write email. I will share the recorded lecture as well, inshallah. If you have any question, you can still ask. Okay, thank you. Thank you very much for your participation. Inshallah, soon we will extend these sessions. And on sample size, there are a lot of requirements, demands from participant. I will do it, inshallah. Okay, thank you. Thank you, Dr. Sayyid Ijaz Saab. Thank you very much. Yes, Miss Aisha, recording will be shared on priority basis, inshallah.